We're now going to find a vector in component form when you're given its magnitude and you're given its direction. Just as before, we need to draw a sketch. So again, we're going to rule our vertical and horizontal axes. Remember, the vertical axis we also call the J-axis. Horizontal axis we call the I-axis, and then label the position of the origin. So we want to sketch this vector from the information that's given. First of all, we always choose to put the tail of the vector at the origin. We're told that the vector is 60 degrees below the negative x-axis. So what I'm going to do now is draw a line from the origin such that it forms an angle of 60 degrees with the negative x-axis or the negative y-axis. So the only place I can draw this line would be somewhere in here, like that. So the angle between the negative x-axis or negative y-axis and the vector is 60 degrees. So we'll mark that angle in there. This is therefore going to be the nose of the vector. And remember, the arrow on the vector always points at the nose. We're also told the magnitude of this vector. We're told that its magnitude is 5 units, so its length is 5, so we'll put that on the diagram as well. Now, I'm going to form a right angled triangle again using the vector and the horizontal axis as two of the three sides. So I'm going to draw a vertical line up from the nose to the horizontal axis like that. Now, at the minute, we don't know what the J component is, and we don't know what the I component is. That's essentially what we're asked to do. Now, we need to do two things. We need to get the signs SIGNS of the I and J components first, and then we need to work out the values of the I and J components. So let's get the signs first. So signs of I and J components. And we get the signs just by looking at the sketch. So clearly the I component here is going to be negative, okay, because we're moving to the left of the origin here. So the horizontal bit between the nose and the tail, this is going to be negative here because this position here is going to be a negative I component. So the I component is negative. And likewise, the J component, which is the vertical bit between the tail and the nose, it's clearly a downward bit. So the J component is going to be negative as well. So J is negative. So we've now worked out the signs of the I and J components. We've now got to get the values of the I and J components. Now, in order to do that, we use right-angled trig. So, let's start with the I component. The I component here is adjacent to the angle, and we know the hypotenuse. So, what trig formula involves adjacent and hypotenuse? It's going to be the cosine formula, so our cos formula. So, let's get our I component. So I component So we're going to use cos theta equals adjacent over hypotenuse. So the angle is 60, the adjacent is what we're looking for, and the hypotenuse is 5. So cos 60 is equal to adjacent over 5. And then we're going to cross multiply, so we're going to get 5 cos 60 is equal to the adjacent. This is going to be our I component. So let's go to calculator. 5 cos 60. So that's going to give us 5 over 2. So 5 over 2 is equal to the adjacent, which will be our I component. Let's do the same for the j component. So going back to our diagram, the value of the j component is the side which is opposite the angle. So we want the side that's opposite the angle, and we know the hypotenuse, so the trig formula involves opposite, and hypotenuse is going to be the sine, S-I-N-E. So to get the j component, we're going to use sine theta equals opposite over hypotenuse. And then we're going to sub in all the information. So remember, the angle is 60. So sine 60 is equal to the opposite. That's what we're trying to find. The j component is the opposite. And that's divided by the hypotenuse, which is 5. And again, we're going to cross multiply, so we'll get 5 sine 60 is equal to the opposite. So again, let's go to our calculator. So we're going to type in 5 sine 60, and then that's going to give us 5 root 3 over 2. Keep it exact. So 5 root 3 over 2 is equal to the opposite. So we've worked out the signs of the I and j components, we've worked out the values of the I and j components, so now we put it all together. So our final answer then, so the vector in component form, the I component's negative, and it's got a value of 5 over 2, so it's going to be minus 5 over 2i. And then to get the j component is negative, and its value is 5 root 3 over 2, so the j component is going to be negative 5 root 3 over 2, and then obviously we've got our j after that. And that is the vector in exact component form when you're only given its direction and its magnitude.